Assalamu alaikum and welcome to another video on our channel. Today we're going to do the pairwise sequence alignment. And a few of you requested this video and it's kind of a tough topic, so I don't know if I'll be able to pull it off, but I'll try inshallah. Now, before diving into the manual procedure, let's first see what alignment actually is. Well, now in bioinformatics, when we align different sequences, they could be DNA sequences or RNA sequences or even protein sequences. When we basically align them, we arrange them in a way to identify the similarity regions and the variation regions in order to make sense of their evolutionary relationships. Now, we know evolution is basically the accumulation of change over time, right? And that change basically leads to a new species, right? In aligned sequences, the evolutionary relatedness basically of different sequences, it points to the fact that they belong to the same family. So if we had some unknown sequence or an uncharacterized sequence, if we identify it as being similar to another sequence that is characterized and we know its structure and function, we can assume that that sequence, because it is similar to that and we can trace it back to a common evolutionary origin, we can assume that it has similar properties to that characterized sequence. And then we have variations, right, between sequences that are aligned, but they have certain varying regions, and they indicate substitutions, insertions, or deletions. Coming towards homologous sequences, basically if the sequences can be traced back to a common ancestral origin, to a common evolutionary origin, we call them homologous. So they're either homologous or they're not homologous. There's no in between. For the sequence similarity, it's quantified in percentages, and it tells us the likelihood that the sequences, whether they're actually homologous or it's due to some chance factor. So we have different degrees of similarity, the midnight zone, the twilight zone, and the safe zone, where we can safely say that these sequences are actually related, right? They're actually homologous, right? So in aligned sequences, we basically have regions that are aligned but they're not identical. They indicate substitutions. Then we have certain regions that where we have no correspondence, where there's a gap, right? And that gap basically indicates insertions or deletions that have come about as a result of evolution over time. Now, the goal of alignment is basically to pair the two sequences in a way to get maximum correspondence, and for that we'll have to shift one sequence relative to the other. We have basically two types of alignment: the Needleman Wunsch method, which is also called global alignment. This basically what it does is it matches the sequences across their entire length, right? So for that purpose, it would be better to have two sequences that are closely related and that they're of a similar size, because otherwise it wouldn't really be an optimal alignment. And now in the case of the Smith-Waterman alignment or the local alignment, we basically just we get the best match. We get the region with the maximum level of similarity, and this can be done with different sequences. They don't have to be necessarily closely related. Now it's important to choose the right alignment, according to your requirement. But if, in case you don't know or you're not sure which alignment to use, it's always better to use the local alignment method. Now, these algorithms are basically based on three methods: the dot matrix method, the dynamic programming method, and the word method. But we're just going to be discussing the dynamic programming method in this video. Now, you could say that there's basically four steps in the alignment procedure: initialization, filling the matrix, then we have traceback, where we find the optimal path, then by scoring we select the alignment with the highest score because that is the best alignment. Now once we do this, you will have a better idea of that. Now as for gaps, like I mentioned before, they basically represent an insertion or deletion, and basically when aligning the sequences, we put gaps so that more terms can match between the two sequences. and we assign gaps a negative value, so as as a sort of penalty to like adjust the scores. And you'll also get a better idea of this once we actually do it. Now in this video we're just going to perform a global alignment. So we assign scores. First of all, we assign negative scores to gap penalties, like I mentioned before. We assign negative or zero scores to mismatches, and we assign positive values to matches. What score exactly you're going to give basically just depends on you. It would actually give a similar result. It doesn't really make that much of a difference. Just remember to give negative values to gap penalties and mismatches, and positive values to matches. I've taken two sequences over here, and they're not really actual sequences. They're just for an example. To begin now, I'll first draw a matrix like this. Basically, we get a matrix of this sort. I've put each term or each base of the first sequence at the top of each column, and I've done the same for the other sequence, but in the rows. Now, if you've studied basic maths, you'll know that for matrices, I represents the row number and J represents the columns. So this basically just means that this is the first column, this is the second column, this is the third column, and so on. Now, the first rule to remember is that before the first term, we basically add a gap column and a gap row. So a gap and a gap would correspond to nothing, because obviously there's nothing there, they're both just gaps. So we put 0 over here, and now we're going to initialize. For that, we're going to put the gap penalty, right? So we'll just basically add the gap penalty. This would be -2, this would be -4, then we have -6 and -8, because as you can see over here, I assigned -2 as the value for the gap penalty, right? And like I said, you can assign it as you wish, but these are the values that I have assigned over here. We'll do the same over here. So you put that, and this is called the initialization or initiation step, right? So that's done. Now coming towards filling the matrix, let's suppose this is the cell that we're going to fill in first. So we'll have 3 values for this cell. One would come from here, the other from here, and the third one would come from here. So let's suppose the value that comes from here, we'll basically just add the gap penalty, and the gap penalty we know is -2, so this would be one value for this would be -4. The other value would come from here, and we'd do the same thing, we'd add the gap penalty. So it would again be -4. But for the value that is coming from the diagonal cell, what we basically do is we add the match or mismatch value depending on whether it is a match or not, right? So how would we know if it is a match or not? So basically this is the cell, and it corresponds to A over here, and it corresponds to A over here as well, and obviously A and A are the same thing, right? They're both adenine. So this would be a match. So if we add +2, which is the match value, to 0, we would get 2. Now, since we have 3 values over here, but we just need one value, so how would we know which value to put? The answer is really simple. We just put the highest value that we get from the three values. The highest number that we have here is 2. So we'll put 2 over here, because 2 is the value that is the correct value for this cell. Now we also need to indicate which of the cells this value came from, because like I just mentioned, we can get the value from any of the 3 cells, right? Like for this cell, we'll get it from any of these 3 cells, and so on. So we need to mention which of the cells we got this value from. So for that, I will add an arrow to indicate which of the cells this value came from. So if it came from this cell, it would be a vertical arrow. If it came from this cell, it would be a horizontal arrow, and since it came from this cell, I will put a diagonal arrow over here. So let's see how I do that, right? Now as you can see, I put a diagonal arrow because the value came from this cell. Now moving on, we'll calculate the value for this cell as well, following the same procedure. And like you might have noticed, in order to calculate the value for this cell, we need the value of this cell. So that means that when filling the matrix, we have to follow a certain order. So first we'll fill this whole row one by one, and then we'll move to the other row and fill that row one by one, and so on. And we need to follow this sequence in order to be able to solve the matrix. Now another way to obtain values to fill the matrix would be through formulae. And these formulae are basically doing the exact same thing, but it's less messy. So I'll show you how to fill this highlighted cell using the formulas. So basically, here we have the first formula. I'm just going to plug in the values right over here. So for this cell corresponds to I1 and J2. Right? So I'll put I minus 1 would be, since I is equal to 1, so I minus 1 would be 0 and J would be 2. Right? And W basically stands for gap penalty, and our gap penalty is minus 2. So this would be minus 2. Right? And this arrow just shows the arrow that we're going to put. Like we put the arrow over here, so it indicates where the value is coming from. So when I do that, x with this coordinate, the value with this coordinate would be basically 0, 2 would correspond to, this is 0, and 0 at the second row is equal to minus 4. So we'll have minus 4, minus 2, which is the gap penalty. So that would become minus 6. Doing the same for the other formula, the gap penalty is minus 2 throughout. So then we'll put our values over here. I is 1 and J minus 1, because J is 2, J minus 1 would be 1. So J minus 1 would correspond to 1. 1 would be 1, 1 is 2. Right, so we'll write 2 over here. 2 minus 2 is equal to 0. Now for the last part, I minus 1 here would be 0, because I is equal to 1, and J is equal to 2, so J minus 1 would be 1. S is the match or mismatch value, and here since A and T are not a match, they are a mismatch, so we'll put 0, because that is the value that we assigned to the mismatch. Sorry for that. Right, so excuse me. So this would basically equal 0, 1 would be minus 2, right? So minus 2 plus 0 is equal to minus 2, right? So now we're going to do the same thing. The highest value over here, minus 6, 0 and minus 2, the highest value would be 0. So we will put 0 over here, and the arrow that we'll put is this arrow, because that is where the value came from. And basically, if you notice, we did the exact same thing, right? Because 0, 2 is this, right? And this is one of the values where the where the value was going to come from, and we would put the vertical arrow if that happened, and that is exactly what the formula says. Same is the case with this, that if the value came from here, then we would do this. And basically it's the exact same thing, but it's a little more, you could say, neat. So doing that, and then we'll put the arrow. Now basically, as you can see, I put this arrow over here, and we're going to fill the rest of the matrix the same way, following a sequence like I told you before, right? So I'll just fill the matrix. Okay, so the matrix is now filled, and we have two boxes where we have put two arrows. So like here you can see that we put a diagonal arrow as well as a horizontal arrow. And the reason for that is if you solve for this, like from the 0, we'll add a plus 2 because this is a match. We have a cytosine and a cytosine over here as well. So this would be a match. We'll add plus 2 to the 0 and we'll get positive 2. We'll add the gap penalty to this and it will be minus 4. And for the 4, we'll again add the gap penalty and we'll get a 2, a positive 2, because 4 minus 2 is positive 2. So we got the highest value as positive 2 and we got it from two of the cells. We got it from the diagonal cell and the horizontal cell as well. So basically this is, the highest value is 2, and we'll put both the arrows to indicate that we got 2 from the diagonal cell as well as the horizontal cell. And the same thing happened here, and we put two arrows, the vertical arrow and the diagonal arrow, because we got the highest value from both of those cells. Alright, so now for the traceback. What we're basically going to do is we're going to move from the bottom right corner to the top left corner, and I've removed all the extra arrows to avoid confusion, and I've traced out the optimal path for like the optimal alignment. And now we're going to assign values. So if we start from here, few simple rules that would really help you to find the optimal alignment are basically, if you're moving from a larger to a smaller value, as in this case you're moving from a 6 to a 4, and 6 is obviously larger than 4, so that means it's a match, and you can clearly see that C and C are obviously a match, so that would mean it's a match, right? And we'll write C over here for that. Then suppose you were moving from a smaller to a larger value, suppose this was a 4 and this was a 6, then this would have been a mismatch. And even if this was a 6 and this was also a 6, like you were moving from the same number, then that would also be a mismatch. But since this is a match, we'll just move forward. Now here we have a horizontal arrow, and when we have a horizontal or a vertical arrow, that indicates a gap. So here we'll put a gap, and to indicate a gap, we'll just put a dash, basically, right? Then moving on, we have another diagonal arrow, and we're moving from a larger to a smaller value once again. So that is once again a match. So we'll put a C over here. Then we'll put, since we're again moving from a larger to a smaller value, we have another match. We'll put a T next to the T. Then once again we have another match, so this would also be an A. Right, so I've added the symbols for the match, right? We draw a line, a vertical line like this to indicate a match, and we draw a horizontal line for a gap. And in case we had a mismatch, we could have drawn we could have put a dot between the braces instead of a line, right? Okay, so now we're finally going to score our alignment. Now for the first part, we have a match, and we assigned a positive 2 value to a match, so we'll write a positive 2. We'll add to this another positive 2 because the second one is also a match. Then after that we have another match, so another positive 2, right? And then we have a gap, so we will add the gap penalty, which we assigned as we assigned minus 2 to the gap penalty, so that is the value that we're going to add. Then we have another match, so once again we'll add a 2, and when we calculate this, it would be 2 plus 2 equals 4, plus 2 equals 6, minus 2 equals to 4, and plus 2 would make 6. So our score is 6. Alright, so remember at the start I mentioned that you can get a different score, and that's fine, but your alignment, the optimal alignment that we've got in this case is, it would be the same alignment, but you can have different scores, because that depends on the values that you assign to your match, mismatch, and gap penalty at the start. So basically, you can assign whatever values you want and you can get a different score, but the alignment would be the same. Now, in case we had double arrows anywhere in the cell, like we had double arrows over here, so we would have two options for the alignment, right? We would get 6 4 6 4 2 0 and 6 6 maybe 4 2 something else, right? Because we would have two arrows, so we would get two possible alignments, and when we would score them, we would compare the scores, and the one with the highest score would be a more accurate alignment. That would be the more optimal alignment, and we would choose that as the best alignment. And here, this is the only optimal alignment, right? Alright, so that's it for the global alignment. In case of the local alignment, what we do differently is that we don't put any negative values in the matrix. Instead, we put a 0. And the second thing is, for the traceback, we don't start from the bottom right corner. Instead, we just start from the highest value in the matrix, wherever that may be. And basically, we'll cover that in another video. For now, thank you for watching. Hope you understood. And if you didn't understand anything, feel free to ask in the comment section. Hope this was helpful. And yeah, see you in the next video.